Hello everybody, my name is Bảo Long, and today I'm gonna present our group number one for presenting the midterm exercise. The state management in Flutter with mobs is our subjects or topics. So next, we're gonna go through the introduction. In Flutter, we work with widgets, and the user's interface is dependent on the state. Managing state effectively and crucial to avoid difficulties in maintaining and scaling application, making it one of the most important aspects of an app life cycle. Sorry. And uh, over that, Flutter is an excellent framework for building Android and iOS application. In Flutter, we work with widgets and users interface, and there are several libraries and packages available to handle state management, such as Provider, Redux, Blocks, Binder, and Solidad. However, the approach I would like to introduce is MobX. It's widely used library that relies on observable and reaction to manage state efficiency. And the next thing we're gonna the next thing we're gonna discuss is state management with MobX. So we can go through the definition. MobX is a signal-based battle test library that makes state management simple and scalable by transparently applying functional reactive programming (TFRP). That is according to MobX websites. You can find it in MobX websites. It enables developers to handle and modify application state actively, ensuring that any state change trigger automatic updates to the user interface. MobX is the state management tool designed for JavaScript application and frequently paired with Flutter, but also compatible with frameworks like React or vanilla JavaScript. It enables developers to handle and modify application state, as we discussed. The core idea is you can see here the core state is represent the essential data and mutable, and the delivery state is calculated on based on the core state and automatically state kept in scenes. So the core idea is the MobX is built on the concept that state can be split into two categories: the core state and the delivery state. The core state represents the essential data related to the business logic being handled, while the delivery state derived state is calculated based on core state, and core state is mutable, meaning that it can change over time, and derived state, which depends on core state, is automatically kept in since MobX related system. And now we're gonna move on and learn about the architecture of the MobX. So, as we see here that the first thing we're gonna discuss is the observable. MobX provide a core building blocks. Here you can see here, yeah, building blocks called observable here. The represent the that that officer represent the reactive state of your application. So it means like observer is like the slide, you can see it right in front of me, that represent the thing that appear on the screen. Yeah. And the next thing is observer. So one of the most reassuring, impactful reaction in the application is the user interface, the UI. The observer, which is part of the Flutter Mobix package, offers detailed observation of the officer memo utilized in its builder functions. Whenever that are changed to this observable, observer automatically rebuild and render the UI and re-render the UI. So it's basically what you can see. Yeah. So the next thing is the action. The action are the mechanism used to modify and observe in mobs. So instead of altering them directly, action provide context and meaning to the change. Additionally, action group are all notification together, ensuring that updates are only sent once the action has finished. This means that observed are noticed only after the entire action been complete in one automatic operation. And the last thing we're gonna discuss in architecture is the reaction. A reaction is like compute value, but instead of generating a new value, it triggers the size effects. The size effect and the reaction configure the side effects. Reaction act like a link between reactive and imperative programming, handling tasks such as logging to the consoles or making network requests. Next, we gonna learn about principles. So the first thing we can investigate in is number one. The deviation are updated automatically and automatically when the state change. And the second thing is all the deviation are updated singularly by default. The third one is compute value update lazily. And the fourth thing is all compute value should be pure. And the next number one is it become impossible to notice state difference. The second one is memorize optimization. And the third one is flexible architecture option, and the fourth one is minimal number of subscriber, and the fifth one is reduce work for developer, and the next one is reduce conflict between the observation and the observable. So this is not the principle. This is the benefit when you have the principle. The principle is actually give you fundamental principle of mobs here. Application can manage state using multiple store. Any value can be computed directly from the state without extra input is called derivation. An action is any piece code that changes the state. Derivation are updated automatically whenever the state change, ensuring that no intermediate value are visible. Complete values are updated easily and they only recalculate when needed for the size effect like IOs. If no longer uses, they use be garbage collected. So the next thing we're gonna um, the next thing we're gonna discuss is the comparative analysis. And we see in here we got two things to comparative, that MobX and ReduxX are both powerful tools for managing state in application, but they differ significantly in approach and complexities. Redux is an application state management framework. Its main objective is to global state in the application. In principle, MobX can have the same, providing uh, comparison between these two approaches that have clarified MobX better. And the performance of Redux, that improving rendering speed directly enhance user experience by reducing jitter, lags, and delay during UI update triggered by any action. This boosts the responsiveness of your React apps. MobX has consistently shown better performance for rendering update like because it automatically tracks dependencies and re-render components selectively when necessary. On the other hand, Redux requires manual optimization to prevent unnecessary re-render and achieve similar performance levels. Scalability. The next thing we're going to discuss is the scalability. Redux is generally more scalable than MobX, but with its structure and opinionated approach to the state management, Redux is better suited for handling complex applications, make it easier to scale Flutter apps compared to MobX more flexible approach. Additionally, because Redux enforces the use of pure function, and they are simplified and simpler to test their behavior and more predictable. So MobX has a way easier to use. MobX Reduce that has stable learning curve due to its strict principle and need to understand the concepts like reducer and action. MobX has a more straightforward API and require less borderless code, making it easier to grasp for beginners. So next thing we're gonna discuss about the state or the state management option. Aside from Redux, let's evaluate several additional techniques to better describe properties of MobX. See, now we're gonna move on to the architecture. Using functional reactive programming, MobX transparently provide cover all the properties in an application state that are defined with the likelihood of changing and rebuild the user interface only when property change is in contrast to other state management pattern in Flutter, such as blocks, and which was founded on the idea that change should be propagated to stream, and Redux, which was found on the idea that an application has a single source of truth from which it inherited. So next thing we're gonna see the pros and cons. State object, like the benefit is no boilerplate, like easier to use. You can see all the benefit and the drawback is the pros and cons of BlockX, and you can see BlockX, MobX, observation, governance, stream, permanent access state. Yeah, you can power this to see. Okay, and thank you for listening. And now we can next thing we're gonna do is we're gonna see the demo. Thank you guys.